Children love to dress up, love to put on fancy clothes, wear face paint, put up their hair, all to try to confuse you that they are not your real children, but they're not very successful. Fractions aren't either. They try to dress up all the time. So for example, 1/5 tries to look different by putting on some clothes and looking like 2/10, but we know it's the same. 7/35, that's the same too. They're trying to confuse you, but it doesn't work. Okay, well, how do you tell if a fraction is dressed up or not? Well, all that we need to do is we need to see if any numbers divide into both numerator and denominator. So 15/30 we can turn into 5/10 by dividing both numerator and denominator by 3. We could also have turned it into 3/6 by dividing both numerator and denominator by 5. Are either of those new fractions dressed up? Well, yeah, both of them are, because we can divide again both numerator and denominator to produce 1/2. And 1/2 is not dressed up. It's your normal child without any accoutrements. Notice that we could have got to 1/2 immediately by dividing both numerator and denominator by 15. Let's say that you wanted to list all of the fractions. You could do that. You could have the first column equal to 1/1, then 1/2, then 1/3, then 1/4, etc. The second column you could start off 2/1, 2/2, 2/3, 2/4, and so on. You could list every possible fraction. But some fractions there are dressed up. For example, do you see down there 4/6? Well, that fraction is dressed up. We've already seen that fraction earlier in the table. It's 2/3. But let's say that you want a systematic way to list all of the fractions that aren't dressed up. Well, this table's not going to do it. Instead, you would want to turn to something like the Calkin-Wilf tree. This is one of the beautiful moments of mathematics. I don't think fractions get any more beautiful than this. You can't see all of this, but Google it, Calkin-Wilf tree. Whenever you go clockwise on the tree, you must add the numerator to the denominator of each successive fraction. Whenever you go counterclockwise on the tree, you must add the denominator to the numerator on each successive fraction. So that means that any time that you're going counterclockwise, you're going to be ending up with a fraction more than 1, and whenever you're going clockwise, you're going to be ending up with a fraction less than 1. Now it's time to play a game that tests your ability to identify dressed up fractions in all of their different guises. Sam starts at the left on a fraction 30/60. Now we both know that that is 1/2 dressed up. All of the fractions that Sam goes on must be equal to 1/2 on his way across to get to this symbol over on the right-hand side. Let's see how we go. 30/60, we can go to 35/70, 2/4, 1/2, 14/28, 7/14. Now let's say I made a mistake. Let's say I said 2/5. Then the zombies come out and I'm in danger. 9/18, I'm back on the right track. 16 divided by 32, 40 divided by 80, 45 divided by 90, and I'm successful. I'm now on level 3. You can see that the fraction now that I have to follow is the fractions that are equivalent to 6/8. Well, I guess that's equivalent to 3/4. So everything has to be equivalent to 3/4. So I could move over here to 12/16, to 30/40, to 36/48, to 150 divided by 200, 12/16, yes. 18 divided by 24, yes. 80, let's say I made a mistake, 80 divided by 100. Oh no! And this time I'm going to make another mistake, 40 divided by 60. I've been outnumbered. So that's the game. Good luck.